I'm just going to talk about the more holistic aspect of this. So if we were to have an economy that pursues improvements in decreasing the use of reliance on fossil carbon at the expense of all else, we would be just as screwed as having an economy that pursues dollars at the expense of all else. Because we would make ridiculous decisions like, well, actually it's better to give those poor people no more access to energy because then they're just going to burn more, right? So we've got to do this in a holistic way. And the SDGs are a perfect expression of this. The interdependencies between these SDGs, actually, if we don't solve the carbon problem, the other SDGs don't really matter. But all of those SDGs do matter in that context. And that's part of the reason why we're involved in this consortium with Future Fit. What we've effectively done is we've looked at what every business in the world will have to do across all the environmental and social issues to ensure that it does nothing to undermine the possibility that humans and other life will flourish on Earth forever. Okay, so you can think of this, we'll talk about the triple bottom line, and we have for many years, and that's never been more relevant than it is today. But if you think about it, we've never really had a clear definition of what break-even looks like on the environmental and social dimensions of the triple bottom line. We know what it does on the financial. You make as much money as you spend, or you're not around for very long. What does break-even look like on the extra financial side? That's what the benchmark sets out, grounded in 30 years of system science, science led by the founders of the Natural Step, which some of you may come across. And what we've tried to do is make the academic rigor of that system science something that's much more actionable for business. So pursuing carbon productivity in the context of this broader idea of break-even is something that's really important. And we've fed into the work that Ben's done to help people understand how to pull these levers in a way that doesn't cause unintended consequences elsewhere. Here's the framework that Ben just showed, and what we thought would be nice, we've all talked about these initiatives being complementary rather than actually being different things. They're just different doorways to the same destination. What we've done here is we've said, well, let's look at how each of these drawdown initiatives actually corresponds to one of these levers being pulled across the value chain. So first one, carbon capture utilization. I'm going to rush through. What we've done there is we've lit up the initiatives where there's a clear relationship with pulling that particular lever. So one example is the work that the chap there is doing around artificial leaves, artificial photosynthesis. Here we have use of recycled inputs. So one example there from drawdown is using ground up bottles instead of limestone clinker in cement, which means it's a lot less intensive greenhouse gas emission during production of cement. We have things like bamboo as a construction material, stronger in some ways than both steel and concrete. Supply chain improvements, so in particular around transport, high-speed rail, shipping and so forth, rather than air freight. Efficiency and process gains, I could go on and on. I'm not going to because lunch is looming. The point is what we're going to do with this is turn this into some kind of interactive tool. So that if someone in a company is in a role related to procurement, for example, they can think, okay, I want to look at what I can do within my supply chain. And then they get a route into the various drawdown solutions that they can explore. Likewise, some of these drawdown solutions are actually pulling multiple levers at once. So these things all interrelate. And I think what we're trying to do is curate and collate everything that's out there into something much more usable and useful rather than creating something new. So there are things about drawdown that aren't related to an industrial value chain pulling a particular lever, but when we went through the mapping, we were quite surprised to see that 87 of the 102 drawdown solutions do have a very clear mapping to these levers. So it's a very useful way of looking at these things. I wanted to end on a high note. There's a startup we were hoping to get here today called Carbon Upcycling Technologies from Alberta in Canada. Unfortunately, they couldn't come because they're a semi-finalist for the X Prize and they've just had a meeting in New York, as John mentioned earlier. They've done some really interesting stuff and they're doing it in a really interesting way, which I hope can really help spark some interesting conversations this afternoon around our 5 discussion themes. So very briefly, they found a way to sequester carbon dioxide into carbon nanoparticles. Okay. So you've probably all heard about graphene, about the potential for carbon nanotubes and so forth to have all sorts of uses in industry that we're only just beginning to understand. What they've done is found a way to do this that sequesters 10 to 30% CO2 by mass in these nanoparticles in a way that's completely locked in and stable up to temperatures of around 300 degrees C. Now, that is a good thing. If you did that and you left those nanoparticles just in a pile on the floor, you've still taken that out of the atmosphere. Right? But of course, that's not ideal. So what they did, and this is the exciting bit, is they sent a load of these nanoparticles to 6 universities around the world who are known for different areas of expertise around material science. When the founder of Porv told me that, I had visions of people in universities all around the world opening envelopes and finding black dust inside. What am I supposed to do with this? But what they did was they sent it round and said, look, we don't know if these are usable or useful or not. Can you let us know? And what they found in 18 months is they can make durable concrete coatings, so that concrete vats used to store corrosive chemicals, the life of those can go from 18 months to estimated around 20 years. They can enable rechargeable batteries through the use of these nanoparticles to have more charge cycles, to go well beyond their standard lives right now. You can see the levers lighting up as we're going. So this is just one startup, one technology that's being deployed in multiple ways through using universities to figure out what's the use cases. More efficient polythene production. Standard polythene production, they can actually just seed the vats of polymers with these carbon nanoparticles, and it means the polymer chains come together much more easily with less energy involved. They can actually paint this stuff onto the surface of solar panels, these quantum dots, these very small nanoparticles. And what that does is that these nanoparticles will react to ultraviolet hitting the solar panels, which normally ultraviolet does nothing with a standard solar panel, but then they convert that into visible light, and they can increase the efficiency of solar panels from around 12% to around 15% just by painting this stuff on, aftermarket stuff. Amazing. And then finally, they're even still at the experimental stage, but looking at how this can enable better cancer drugs, because the surface area of these nanoparticles is massive compared to their physical size, so you can get a lot of drug in a very localized area, which means they can target cancerous cells much more efficiently. How awesome is that? So that's just one startup to show what's possible. Thank you. So just one example of what's really possible all the way through the value chain by pulling these various levers. Thank you.
Thank you.